Hello, and welcome to the latest episode of Becoming Multiplanetary. I'm Rich LB, one of your co-hosts for Becoming Multiplanetary, and I'd like to introduce my co-host, Kage. Kage, would you like to introduce yourself?
Yeah, absolutely. Hello, everyone. I am Kage, also one of the co-hosts of Becoming Multiplanetary, and this is the second part of a two-parter of a mega series about rovers on Mars. In this episode, we'll be talking about the Opportunity rover. In the previous episode, we talked about the Spirit rover, and we went into a few breakdowns about Spirit, as well as some details about both rovers, including some backstory about why the Mars Exploration Rover mission was put together, how it's part of the larger Mars Exploration Program, how Spirit and Opportunity got their names, why Mars, and also some information about the Mars Exploration Rover, twin rovers rather, including where they landed, where they or what their mission objectives were, some specifications about the rovers, as well as how they landed. So today we'll be going into some details about Opportunity specifically, but also some more information about both rovers since they were built identical to each other, including the instrumentation, their drivetrain, computer systems, and power systems. So to begin, let's actually go ahead and kick this off with a video from NASA, which is from, I'm not exactly sure when that's from.
It encapsulates the story of both Spirit and Opportunity as well, so not only is it going to be a nice little recap for you guys for what we talked about last time in the episode concerning Spirit, but it's also going to go over some of the stuff we are going to be going over today in the episode as well. So it's going to be a nice recap and a preview of what we're going to be going over.
Yeah, and this one comes from January 9th, 2009 from NASA.
So shall we go over and head to see that video now?
Yep.
Alright, enjoy.
Green board. 5, 4, 3, 2, 1, engine start, and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars. 3, 2, main engine start, 0, and liftoff of the Delta rocket with Opportunity, a chance to explore and unlock the secrets of our neighboring planet.
We're on Mars, everybody.
The two landing sites are very different, and we've used the two vehicles very differently since we arrived there. Opportunity's landing site is smooth and flat. You can drive for miles. It's all very easy. Spirit's landing site is very rugged, very rocky. Moving around is much more difficult. A Spirit's landing site is at a higher latitude, so the winters are much more severe, and so coaxing that vehicle through a cold, dark Martian winter is a much tougher job than it is for Opportunity.
Now, they are well named. Opportunity really has been incredibly opportunistic and lucky. It basically found water from its lander. It's been able to do all kinds of things because it was lucky. like being able to drive into these craters. It found its own heat shield, and we were able to examine for the first time a heat shield that was used on another planet because it happened to land nearby. Spirit really has had to have a lot of spirit to keep going. It's been the little rover that could, in a way. It's had to work very hard for all of its discoveries.
These are phenomenal vehicles, so well engineered and designed and built that they've been able to last, but they've been able to do this very challenging, dangerous exploration of the surface. I mean, they are very much intrepid explorers, you know, are proxies on the surface of Mars, you know, going forth to explore this hostile and alien world.
Mars is a nasty place. And one of the things that Mars does is every so often blows up into a global dust storm. Our third summer on Mars, it happened. The storm went global, you know, blocked out the sky. If you were sitting at the surface of Mars where opportunity was, the amount of direct sunlight hitting the solar panels was less than 1% of what it would be with a clear atmosphere. You could barely tell where the sun was in the sky. This is a very scary thing if you're a solar-powered vehicle, obviously. And yeah, it was this kind of helpless feeling. You're sitting there and Mars is doing what it does, and it's, you know, you sit there feeling like the planet's trying to kill our rovers. And we had this very challenging job of managing this tiny amount of power that we had on board the vehicle. The bad wheel on Spirit has been both a curse and, as it turns out, a blessing. The curse part is obvious. It's very hard to drive that vehicle now. Spirit's in some pretty tough terrain anyway, and now you're dragging this dead wheel through the dirt. You know, 10 meters is a really good day for Spirit these days. But it's had a wonderful silver lining.
These trenches that she was digging, that just sort of naturally happened by dragging a wheel through the dirt, had these bright patches at the bottom. Some of those patches turn out to have a very high, like 90% silica content. And the way you get a high 90% silica content is lots of water activity. So by dragging Spirit's broken wheel around, she actually turned up some of the best evidence we found of water on either vehicle so far on Mars.
Getting the Victoria was great. I mean, it was 21 months of trudging endlessly across these plains and hardly seeing the scenery change at all. And then one day we're right at the rim of it, and there's just this spectacular scenery, this fabulous geology laid out in front of us. And yeah, the combination of just what a glorious view it was, plus so much effort that went into getting there. Pulling up to the rim of Victoria was, to me, one of the really special moments in the whole mission. How do I feel about the fact that it's gone on for 5 years? Exhausted. I mean, really tired. You know, I thought we were going to get maybe 6 months out of these things. I never thought we'd get 5 years.
I was one of the optimists that felt the rovers would survive the first winter and that we would have an extended mission. But I never thought they would last through 3 Martian winters and continue to explore for 5 years.
I never in my wildest imagination believed it was going to go on for 5 years and give me this opportunity to see so much of Mars and for so long, and to learn so much about, not only about the vehicles, but about the science of Mars and about, you know, the area in which they landed, and to just have this opportunity that I thought was going to be a terrific little kind of short honeymoon, just kind of go on and on and on and on and on, and just get better all the time.
We're going to push these rovers as hard as we can for as long as we can. You know, as long as they keep on moving, as long as they keep making discoveries, it is our responsibility to push these vehicles until they drop.
The rovers have made Mars familiar to us. You know, prior to their landing, it was this mysterious place. And even though we had had successful orbiting missions, we didn't have a human perspective on Mars. It was always a very distant perspective. The rovers have given us that human perspective, and now it is familiar to us.
Mars is such a complicated place, and these are such capable vehicles, that there will never come a time when we're done. Regardless of when this mission ends, whether it's tomorrow or 5 years from now, there's always going to be some wonderful, tantalizing thing just beyond our reach that we didn't quite get to.
When our children and grandchildren bring home that science book where it says, there is evidence of liquid water on Mars, to know that you helped build and operate and direct the rover to that spot, that's very rewarding.
We're tired, but there's just nothing more fun than getting up in the morning and going to work and seeing something nobody's ever seen before, and then deciding, all of us sit down together today on this planet to decide what's going to happen tomorrow on that planet. I mean, that's fun.
Wow, that was a really interesting... I love these videos that NASA make. They're really great.
The thing that I kind of found clever was how Scott Maxwell, the rover driver, he I don't know if he realized that he did it, and it was a bit of a pun, or if it was just opportunistic, but he kept saying he was saying twice about the broken wheel, and or rather about the 5-year duration of its mission, that it kept giving him an opportunity, and that this is a great opportunity. And it's like, ha 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 ha. See what he did there? Yeah. Really good. So, there was a lot of science that both of the rovers did, and Rich, why don't you walk us through some of the instrumentation that was used to perform this science? And bear in mind, from the previous episode in Spirit, we talked about how the both rovers carried about 5 kilograms or 11 pounds of instruments, and that's Earth weight. On Mars, it was only about 2 kilograms or 4 pounds. So really a light amount of instruments, but they packed a lot of scientific ability in those. Rich, you want to walk us through those?
Sure, yeah, no problem. So, if you imagine the Spirit and Opportunity rovers, the vertical mast cam, where its head is. So, on that 1.5 meter tall assembly, there are 3 instruments, right? So, you have the panoramic cameras, which were 2 cameras with color filter wheels for determining the texture, color, and mineralogy and structure of the local terrain. So you can see these sort of calibration things. You see pictures of them from the recent Perseverance mission as well. They look like little sundials, kind of, with different colors. Then we had the navigation cameras, navcams, which were 2 cameras that had a larger field of view. So if you imagine when you're at home and you have your mobile phone, you can take a panorama where you can just keep going around. So that's just like a larger field of view, but lower monochromatic resolution, and it was used for navigation and driving. And then the periscope assembly for the miniature thermal emission spectrometer, that's a mouthful, which identified rocks and soil suitable for closer examination and was used to determine the processes that formed them. So there were also, actually, for the rest of this as well, there were also 4 additional monochromatic hazard cameras mounted on the rover bodies themselves. So you had 2 in the front and 2 behind. So these are lower down on the rover's body, so they can get a sort of lower look at the ground as it goes forward, so you can determine if there's any hazards coming up. Also, if there's any hazards behind, because obviously the terrain on Mars, if there's a lot of wind, it may not necessarily always be static. Something might roll in behind you. So it's good to have these hazcams on the back too, especially when you're backing it up. Yeah,
they didn't always drive forward. Matter of fact, there was a good period of time with Spirit that because its broken front wheel, it was driving in reverse. So those hazcams, especially on the rear side, really became useful at that point.
Yeah, for sure. And then the rovers also had instrument deployment device, also called the rover arm, which held all the following instruments just in the arm. We have a Mersbauer spectrometer called MIMOS 2, used for close-up investigations of the mineralogy of iron-bearing rocks and soils. We have the Alpha particle X-ray spectrometer, used for close-up analysis of the abundances of elements that makes up rocks and soils. The microscopic imager, used for obtaining the close-up, high-resolution images of rocks and soils. And then the rock abrasion tool, used for removing dusty and weathered rock surfaces and exposing fresh material for examination by the instruments on board. And they also had several magnets as well, used for collecting magnetic dust particles, which is interesting. I don't know if you realized recently, there seems to be a lot of magnet fishing catching around. It seems to be going, it's like a fad. Just going with a magnet and reeling it along a river, just catching particles and stuff. But yeah, lo and behold, they had the same thing. Those particles were then analysed by the Mersbauer spectrometer and X-ray spectrometer to help determine the ratio of magnetic particles to non-magnetic particles and the composition of any magnetic minerals in the airborne dust and rocks that have been ground by the rock abrasion tool.
Yeah. And speaking of the rock abrasion tool, there's also, this is an interesting bit of trivia for especially people from the United States, that there were pieces of scrap aluminum that were recovered from the World Trade Center after the September 11th, 2001 terrorist attack, and they were turned into a protective shield that was placed on the rock abrasion tools on both Spirit and Opportunity. The Mars Exploration Rover team revealed this in 2011 as what they called a, quote, quiet tribute. That's really cool, actually.
So, should we talk a little bit about the drivetrain of these things?
Absolutely. Go for it.
All right. So, the rovers use a 6-wheel drivetrain design that was first used on Sojourner, and we'll come back to Sojourner in a later episode. But it was called a rocker bogie system. Now, this is the little sort of legs that dangle down on the rovers when they engage on the floor. And this consists of a main rocker arm attached to the rover chassis on a pivot point with a wheel at the front of the rocker and a bogie on the back of the rocker, which has 2 additional wheels on either end of the bogie. A bogie is the name for the dual wheel assembly you often see on trains, which is basically just a sub-chassis that carries a wheel set. This rocker bogie system gave the ability to keep the rovers stable at up to 45 degrees of tilt in any direction, which is pretty impressive when you think about it. It's pretty much like, what? So here's your 90 degrees, 45 degrees, and it'll still stay stable. This is pretty impressive. And in any direction, too. Although, having said that, to provide safety margins, NASA always kept this under 30 degrees. Spirit and Opportunity were the first rovers to use a rear bogie system, whereas their predecessor Sojourner used a front bogie system. In order to provide tight maneuvering capabilities, both the front and rear wheels could steer, which allowed both rovers to spin in place if needed. The rocker bogie used on Spirit and Opportunity were highly successful, and are still used to this day on both Curiosity and Percy. While the rovers both had a top speed of 50 millimeters per second or 2 inches per second on flat hard ground, they averaged only about 10 millimeters a second due to the hazard avoidance system causing them to stop every 10 seconds to observe the terrain for 20 seconds and then calculate the next few centimeters of travel. And that actually segues nicely right into the computer system, Kage.
Absolutely, thank you. So, and also the observation of the terrain and calculation of its next place to travel to is where those HazCams in the front and the back really came into play. So, in order to do these calculations, the computer system on board Spirit and Opportunity used the RAD 6000 processor, which was designed by IBM and manufactured by BAE Systems, based on the IBM RS-6000 and PowerPC 601 processors. These were actually processors that later, or were the predecessor for what's you would start to see in Apple Macintosh computers using the PowerPC design. Interesting little factoid about that the processors that were used in Power Macs from the early 2000s, those were actually direct. Those were the consumer version of the processors that are today in both the Curiosity and the Perseverance rovers. So, that's pretty cool. So as of 2008, there are over 200 RAD 6000 processors in space on a variety of NASA Department of Defense and commercial spacecraft, which include Spirit and Opportunity rovers, as well as the Mars Polar Lander, the Mars Climate Orbiter, the Mars Odyssey Orbiter, and many, many others. It's really a robust processor, and that's because it's designed to be extremely radiation hardened. So it's able to have a very quick recovery to any kind of radioactive interference or cosmic rays and so forth. It also helps that the processor runs the VxWorks multitasking operating system, which has a lot of error correction built into it, including also the memory on board, which is error correction memory. And that processor runs at a whopping 20 megahertz, which is just blazing fast. It doesn't really sound that fast, but you have to bear in mind that in order to have the kind of tolerances that are needed to withstand the background radiation that happens on Mars and also in outer space, where there's no no magnetosphere to protect those processors from solar rays and so forth. That nowadays we talk about like 10 or 7 or 5 nanometer processes in processors, and for these they're actually much, much larger. I'm not exactly sure, but I think they're somewhere closer to like the 40 or 50 nanometer size. And that's really because the smaller you get with those with packing transistors in a processor, the higher the likelihood is that you can actually have electrons jumping those FET gates, be they I think they're now in GAA FET, but I forget what the current FET gates are that they're using. But you can actually have basically a form of quantum tunneling where the electrons can jump through and cause miscalculations. And so in order to prevent that from happening, they go for much bulkier transistors in these processors, which give them greater room for a greater margin for error. So when you have a much larger processor like that, you also don't have the ability to go very fast with them. So 20 megahertz, good enough for Mars. Although, that being said, the Curiosity and Perseverance rovers are actually an order of magnitude higher. They're at 200 megahertz, but they're running the RAD 750 processors. So they made just a little bit of some improvements when it came to Curiosity and Perseverance. But going back to Spirit and Opportunity, they also ran 128 megabytes of RAM. That's a whole lot there. 256 megabytes of flash memory and 3 megabytes of electronically erasable programmable read-only memory, or EEPROM, which is non-volatile memory. And we covered this in the previous Spirit video, that the memory on Spirit especially had a lot of issues over time, and that actually started from the very moment that it landed. They had to reformat its flash memory, do some various corrections and deletions of things, and they did the same to Opportunity while it was still en route to Mars. And that resolved its issues and was able to continue. They were both able to continue their missions. And also, as covered in the previous episode, on the 1,800th Martian day, or Sol, as it's called, Spirit really began to have some issues with its memory, where it confirmed it received instructions, but it actually never did do anything with them, and it also didn't write anything to its memory. So it was supposed to perform some scientific observations and never wrote that to its EEPROM. So they made some discoveries after a little bit of investigation, that it appeared that damage was beginning to build up from cosmic radiation. Spirit really had a rough journey, but Curiosity kept going. Opportunity kept going for quite a long time. And part of that was because of the power systems that were on board, which as was mentioned in the first video that we just watched, they didn't expect them to last that long, only planning for 90 days. But in fact, for Spirit, it went for about 6 years, and for Opportunity, it went for around 15 years. So, Rich, you want to tell us a little bit about the power systems that were on board?
Absolutely. So, Spirit and Opportunity were both powered by 2 rechargeable lithium-ion batteries, no different than what you would get in the shop. A lot of them are powered by lithium-ion, and they weighed 7.15 kilos or 15.8 pounds each, and that is Earth weight. So Mars weight, they weigh about 2.7 kilos or 5.98 pounds, just shy of 6 pounds on Mars. Now, these were recharged using triple junction solar arrays, which generated about 140 watts for up to 4 hours per Martian day, or Sol, as they're referred to. Now, about 100 watts were needed for the rovers to drive, so moving around obviously consumes quite a lot of energy. Now, while the rovers did carry 8 radioisotope heater units, these were only used to keep the Webb box heated at night. So that's the warm electronics box. And it was augmented by the electronic heaters used only when necessary, when the radioisotope heater units combined 8 watts of output wasn't enough. And this is because the surface of Mars can drop to as low as negative 73 Celsius or negative 100 Fahrenheit, and the electronics needed to stay above negative 40 Celsius, which coincidentally is also negative 40 Fahrenheit, to remain operational. Now, the solar arrays actually hovered somewhere between the region of about 300 watt-hours and 900 watt-hours per day, which was far above NASA's expectations, and the windstorms kept the solar arrays relatively clean of Martian dust, which let them remain in operation for several years longer than what was originally planned. However, it was ultimately this Martian dust covering the solar arrays that led to Spirit completing its mission in 2011 and Opportunity completing its mission in 2019. And we'll hear more about these little dust devils and stuff later on.
Indeed. And in fact, it was because of these issues that the Curiosity and Perseverance rovers were developed to use multi-mission radioisotope thermoelectric generators, or MMRTGs, as their primary power source. And speaking of dust covering Opportunity solar panels, that event is what led to KPCC science reporter Jacob Margolis to sum up Opportunity's final message as, quote, "My battery is low and it's getting dark." In fact, this wasn't Opportunity's final message, just a poetic paraphrasing. Opportunity's last message was a final dump of its memory, which included data indicating that it was low on power and its solar arrays and sensors could not detect or absorb much of any sunlight as a major sandstorm was rolling through, and was ultimately what led Opportunity to its final fate of being shut down on February 13th, 2019. And with that, let's actually go ahead and check out a video from Jim Bridenstine, the former NASA administrator, where he talks about Spirit and especially Opportunity and the accomplishments that that rover brought until its final moments.
This is a celebration of so many achievements. And I'll just start by saying, you know, when this little rover landed, the objective was to have it be able to move 1,100 yards and survive for 90 days on Mars, 90 sols. And instead, here we are 14 years later, after 28 miles of travel, and today we get to celebrate the end of this mission. So it's an honor for me as the NASA administrator to come out here to this amazing facility with so many amazingly talented people to say thank you for your great work, not just for our country, but for the science that people are going to be benefiting all over the world. They're going to be benefiting from this science for years to come.
Spirit and Opportunity may be gone, but they leave us a legacy. And that's a legacy of a new paradigm for solar system exploration. A robotic geologist on Mars and an integrated science and engineering operations team here on Earth all set out together on a mission of discovery. They didn't know what they would find. They didn't know which direction they would go, sometimes from one day to the next. And they made it work. And they made it work longer than any of us thought possible by both brilliant scientific deduction of where to go and brilliant engineering to keep the rovers alive.
Confirmation of a safe landing. We're seeing it on the LTP. Very strong on LTP.
Opportunity hit a hole-in-one when she landed. The airbag system rolled into the small crater called Eagle Crater. And when the rover first turned on its cameras, it saw that the rim of the small crater was lined with exposed bedrock.
So we took out our microscope for the first time and we took a picture, and the surface of Mars at that location is littered with an uncountable number of little round things.
That were called blueberries because they looked like blueberries in a muffin. What we discovered was that those are features that form in water, and they were a really definitive sign that there had been liquid water on the surface of Mars sometime in the past.
You know, after we left Eagle Crater, we went to Endurance Crater, and that's the crater we drove down in. And there we did what the geologists call an in-sequence stratigraphic section, which is essentially reading the chapters of the Martian history book in reverse order.
That rover became a stratigrapher. First time you had a stratigrapher on Mars. We knew we wanted to go after Endurance to Victoria.
We put pedal to the metal and we started heading there, tens of kilometers away. We had to literally surf across these dunes of wind-blown material, and the rover got stuck in one of those. We had to get the rover unstuck. What we found is the best way to get it out is just to put it in reverse and gun it. The rover eventually popped out. And so we changed our driving strategy. So we recognized these ripples as hazards. We get to this giant half-mile diameter crater, Victoria Crater, and we want to figure out, gee, how can we go into this thing?
All of a sudden we got high-rise images. We could see the rover in the image.
And that was the very first image that we got from space showing one of our rovers.
We spent a year scouting the edge of that crater to decide where we wanted to go in to get the best stratigraphic section.
We found a place to go in, and we drove down in, and we spent about a year inside Victoria Crater.
The science team was really excited about the idea of driving to Endeavour Crater, over 20 kilometers away. This is a long drive to do. It was going to take multiple years, but they decided to do it anyways.
There were too many of these dangerous ripples in our way, and we actually had to take this circuitous route that at times took us away from the crater, only to then cut back and then approach it more directly.
And then we pull up to Endeavour Crater, and all of a sudden there's all these new things to look at.
We first discovered the homestake vein. It was this very, very bright linear feature. It turns out that it was a big gypsum vein, and we see these gypsum veins now all over. So it was our first taste of what is a really important process on Mars.
We were driving to a valley, and along the way there we realized that right about the point where we were about to get to this valley, that was when we were going to cross the marathon mark. So we said, well, that's cool. We're just going to name this valley after that, call it Marathon Valley. That was when we reached the distance of a marathon, 26.2 miles on another planet. We continued driving through some slopes down a little bit on the interior of the crater rim until we came back out so that we could continue on to the next valley, Perseverance Valley,
where the rover was exploring when we lost contact.
We said we're going to operate this vehicle until the day where we can't, and that's exactly what we did, and I'm really proud.
We've set a foundation that will serve as the basis for future exploration.
Yes, there we have it.
Those are really some spectacular views, weren't they?
Best line of that video? Just stick it in reverse and gun it.
Yeah, right? So, in honor of Opportunity and its incredibly long mission and several extensions, let's go through a few key highlights over its lifetime. We won't go through everything because there are about 14 close to 15 years of milestones. We'll be here all day. But let's just go through about like 6 or 8 of them. To begin, in 2005, actually, ever since Opportunity's second day on Mars, it had joint pain. So I'm sure I'm sure a lot of people can relate to that. The heater on its robotic arm shoulder azimuth joint, known as Joint 1, was stuck in the on position, likely due to a failure during assembly or repeated testing on Earth. And because of the extreme temperature fluctuations on Mars and the need to put Opportunity into a deep sleep at night due to preserve its power, they could not keep the heater on for that joint. So they actually ended up shutting it off. So eventually, this led to the Joint 1 azimuth motor periodically stalling due to the constant temperature fluctuations, which is why from that point forward, they kept the robotic arm stowed in front of the rover instead of under its deck as designed, which was to reduce the potential of it getting permanently stuck due to a failure. Additionally, in 2005, after exiting Endurance Crater in January, around Sol 345, Opportunity was driven to examine its own discarded heat shield, as we saw in the video just a moment ago. Yeah. And it was also around this time that it discovered a meteorite named Heat Shield Rock, since it was within proximity of the heat shield. And that actually marked the first time that a meteorite was identified on another planet. Not another planetary body, because, of course, that there were meteorites that were discovered and analyzed on the moon, on the surface of the moon, but rather on another planet. And then fast forward a couple years later, in 2007, we get to the first real challenges that Opportunity faced with its power system. Rich, you want to talk about that a little bit?
Sure. So towards the end of June in 2007, a series of dust storms began clouding the Martian atmosphere with dust. We saw this. There was a still from the video where you saw gradients of how dark it got. I don't know if you recall that shot from the video. And the storms intensified, and by July 20th, both Opportunity and Spirit were facing the real possibility of systems failure due to the lack of power. NASA released a statement to the press at that time saying, we're rooting for our rovers to survive these storms, but they were never designed for conditions this intense. And that goes to show how, the NASA scientists thought, oh wow, this is pretty bad. We're going to have to say something here because we genuinely don't think we're going to make it.
Also, not long after that, when those dust storms had passed, that's actually where the first opportunity of dust devils cleaning off the solar panels started to happen, and where the NASA team really started to gain the confidence that they might actually be able to extend the missions, that the rovers, especially Opportunity in this case, might be able to actually survive a Martian winter and continue on. And lo and behold, they both did. For Spirit, about 5 years. For Opportunity, close to 15 years. Thanks to the Martian wind continuing to dust off the solar panels a little bit here and there. So that's really cool. Yeah. Fast forward about 3 years. By March 24th, 2010, Opportunity had driven more than double the distance of its sister rover Spirit, clocking in about 20 kilometers or 12 miles. 2 months later, Opportunity exceeded the record set by the Viking 1 lander for the longest continuous operation on the surface of Mars, 6 years and 116 days.
Speaking of records, actually, fast forward again another 3 years, and May 16th, 2013, Opportunity passed the previous record for the furthest distance traveled by any NASA vehicle on another celestial body, which was 22.21 miles or 35.744 kilometers. And that was a record set by the Apollo 17 lunar roving vehicle in December 1972. So this was a while ago.
Absolutely.
And then on the way to Endeavour Crater in 2015, they were passing by a valley, and they realized on the odometer that they had gone the length of a marathon. So as they said in the video back there, they just named the valley Marathon Valley. So that was kind of cool, actually. And obviously the length of a full marathon being 42.1 kilometers or 26.2 miles. And they accomplished this on Martian Sol 3,968 with a drive, I think it was about 157 meters.
Yep. And that was along the valley along the edge of Endeavour Crater. Speaking of Endeavour Crater, it is massive. Rich, how massive is Endeavour Crater?
Well, I just found out today that apparently you can comfortably fit the entire of Washington, D.C. in the crater.
That's pretty huge.
Yeah. You want to take away the last one?
Yep. So the Opportunity rover continued its mission for 4 more years until finally one more dust storm started to really seal its fate. And that was when it was reaching the westernmost edge of the Endeavour Crater. And actually, on February 13th, 2019, the total rover odometry for Opportunity read 45.16 kilometers or 28.06 miles. And also on that day is when NASA officially declared its mission coming to a full end, when they were no longer able to reach it by any kind of radio wake signals, and it was no longer sending any pings back to either the orbiters around orbiting Mars or back to Earth. And that's where KPCC science reporter Jacob Margolis poetically summed it up that my battery is low and it's getting dark. So rest in peace, Opportunity. The world fell in love with you. The world's heart broke. Mine did as well when it was finally declared in early 2019, that it had reached the end of its mission and finally fully shut down.
Yeah, but man, it went for a long time. Considering, remember, it was only supposed to be a 90-day mission.
90 days, and it went for almost 15 years.
Yeah.
Amazing.
And that's about all the time we have on this week's episode of Becoming Multiplanetary. I've been Rich LB, one of your co-hosts for Becoming Multiplanetary.
And I've been Kage, also one of the co-hosts. If you enjoyed the content that you've been watching or listening to, definitely make sure to like, share, and subscribe. And you can check out the other videos and podcasts that we've done in this Rover Mega Series. We started with the Curiosity rover, and started with the Perseverance rover, and then talked about Curiosity, then Spirit, now Opportunity. And we will be closing this Mega Series with a discussion about Sojourner and the Pathfinder mission. And that'll wrap everything up there. This is not only the only show on the Total Space Network. Becoming Multiplanetary is one of 3 shows. We also have Deep Dive with Miko and the Space Update with Ryan. So definitely check us out on totalspace.net. It's our website where you can find all of our content and links to all of our social media, which, by the way, you can find us on YouTube at Total Space and on Twitter at Total Space Net. And to wrap this up, Rich, would you like to do what you always like to do?
As always, at the end of each episode, we like to take a moment to thank our Patreons, whose help is truly appreciated. The funds that we receive through Patreon is always reinvested back into Total Space, and we use it to bring you even better shows, like improve the quality, for instance, one of the things we did is we got a system for our website which distributes our podcasts everywhere, and it's a really great system and it works really well. So yeah, we're really, really grateful for your support. Lately, we've even managed to get Adobe licenses for video editing as well. So your support really does truly help us. Thank you so much. And our Patreons are Adrian Moiser, Anthony Mann, Fremrick, Gio Pagliari, Howard Walker, Dishman and Sebastian from To the Future, Angry Astronaut, Marco, Sammy Oscuro, also known as Stinger NSW, Susie R, Warhawk, and What About It. Thank you all so much. Your donations are very, very much appreciated by the whole team.
And if you'd like to also join us in our Discord, you can gain access by becoming a patron at patreon.com/totalspace. And with that, then thank you for joining us. Make sure to join us for the final of this series where we talk about Sojourner and Pathfinder. And until then, see you next time.